Welcome back everyone, I'm Beliz and today we are continuing our deep dive into facility planning. In our last video we talked about the foundations, but today we are getting into more math and the methods. We are going to look at the discrete space location techniques, especially how to choose the absolute best spot for a new location using qualitative, quantitative, and hybrid methods. Let's get started. First, a super quick recap. When we talk about finding a location, we are usually dealing with either continuous or discrete space. Continuous space means you can theoretically build anywhere on the open plane, which is infinite and usually pretty unrealistic in the real world. Discrete space, which is our focus today, means we have specific finite list of pre-selected candidates. Think choosing between three specific industrial parks in a different cities. Today we are solving for a single facility location as well using these discrete alternatives. When you have your list of candidates, how do you pick? We generally use three approach. First is the qualitative approach, like a factor rating. This is subjective. It relies on scores, feelings, and expert opinion, mostly expert opinion. Second is the quantitative approach, like transportation model. This is all about hard numbers, usually minimizing distribution costs. And finally, hybrid analysis. This is the sweet spot where we combine objective math with subjective factors for a truly balanced business decisions. Let's look at qualitative side first, factor rating. This is a highly structured way to process subjective opinions. It has 5 simple steps. First one is to identify the factors, what actually matters. Labor cost, climate, proximity to suppliers, and then assign weights. Give each factor weight between 0 to 1 based on how critical it is. Score location rates every candidate location against those factors, usually on scale 0 to 100, and then compute, multiply the scores by weight to get weighted scores, and sum and select, add them all up, the highest scores wins. Let's look at an example. With juice company example. They are looking at Antalya, Izmir, and Bursa to expand, to open new facilities. We have listed our factors, things like proximity to food supply, transportation, access, labor cost, land cost, utility cost, and etc. We gave them weights and we score the cities. When you do the math, Antalya comes out the top with scores of 81.85. But remember the note at the bottom. This is a subjective. Before we break ground in Antalya, we really need to look at hard logistic cost as well. Okay, now let's look at the quantitative analysis, the transportation model. This is classical linear problem. The goal here is simple and ruthless, minimize the shipping cost. We take our existing plans at the candidate new plant and figure out the absolute cheapest way to ship goods from those sources to all of our destinations while meeting supply and demand constraints. Let's stick with our juice company, but look at the numbers. They already have plants in Adana and Mersin, but demand is up. They want to open a new plant in either Konya or Kayseri. We have our cost tables here. We know exactly how much it costs to ship 1 unit of juice from any place to our distribution centers in Ankara, Istanbul, Izmir, and Antalya. To figure out the winner, we have solved the model for both options. Let's test the Konya option first. In operation research, we usually start with initial feasible solution, often using sometimes simple like northwest corner method. It is fast, but it ignores cost. To get the actual cheapest route, we use MODI method, modified distribution method, to optimize it step by step. When we run the optimal solution with Konya as our third plan, our total minimized transportation cost comes as 7,980. Now, we do the exact same process for Kayseri option. When we run the MODI method for Kayseri, the optimal cost comes up as a 9,510. The conclusion here is purely mathematical. 7,980 is less than 9,510. Therefore, the juice company should build their new plant in Konya to minimize their total network transportation costs. And this is the implementation of the GAMS model. As an industrial engineers, we are doing this massive MODI calculation by hand on whiteboard. We use softwares. Here is how you implement this exact transportation model in GAMS, General Algebraic Modeling System, which is on the left. You can see the code. We define our sets, the plans, and the centers. Our parameters, supplies, demands, and the unit cost table, and our variables. Finally, we write supply and demand equation to tell GAMS to minimize objective cost. Objective cost variable Z. If you look at the output on the right, the objective value is 7,980. The exact same optimal solution we find for Konya calculated in the fraction of second. So we are look at the purely qualitative feelings and purely quantitative costs. But in real world of industrial engineering, decisions are rarely that black and white. That's why the ultimate tool for discrete space location is hybrid analysis. Hybrid analysis combines everything into one master formation using three types of factors. First one is the critical factors. These are the must-haves. They are simple yes or no. If location fails a critical factor, it is immediately eliminated. Second, objective factors. These are the hard measurable costs we just calculated, like transportation, energy, and taxes. Third one is the subjective factors. These are the qualitative aspects, like community support or expansion potential, which we rate on a scale and assign weights to. Let's bring back our expanding juice company to see how this works. Management is now evaluating four candidate location. Kayseri, Konya, Karaman, and Niğde. They want to combine two critical factors, one objective factors, which is our total annual cost, and four subjective factors. Pay close attention to this part. Management has decided that the objective factors are going to be weighted at 0.4. We call this our alpha. This means the subjective factors will make up the remaining 0.6 of our final decision. Let's do the calculations. Step 1 is the most ruthless, calculating the overall critical factors. Because critical factors are yes or no, we represent them as ones or zeros, and we multiply them together. Look at the Karaman. It has adequate water supply, but completely failed to get zoning approval. 1 times 0 is 0. Because of that single zero, Karaman's total critical score is 0. They're officially out of the running. We don't even need to look at their cost anymore. Konya, Kayseri, and Niğde pass with score of 1. Now let's move on to step 2. Is normalizing our objective factor, our cost. Since Karaman is eliminated, we cross them out of the big red line here. Looking at our remaining 3, we identify the maximum cost, which is Niğde at 450, and the minimum cost is Konya at 350. We plug these into our objective factor formula. It is basically scores how close the city is to the cheapest options. Konya is the cheapest, so it gets a perfect objective score of 1 to 0. Niğde is the most expensive, so it gets 0. Kayseri sits right in the middle with 0.5. Now let's move on to step 3. Step 3 is dealing with the subjective factors. These look exactly like the factor rating method we did earlier in the video. We take the weight of each factor, like 0.4 for proximity to food, and multiply it by the city score for the factor. We do this for all the subjective columns and sum them up. After the math, Konya gets the subjective score of 0.830, and Kayseri gets 0.790, and Niğde gets 0.7. As the last step, the grand finale, we calculate the ultimate location measure. The formula looks complex, but it is just blending our work together. We take our critical score, which is 1, and multiply it by the blend of our objective. When we calculate the final blended scores, Konya comes as a 0.498. Kayseri scores 0.674, and Niğde scores 0.820. So here's our final conclusion. Even though Konya was technically the cheapest option on the paper, when we factor the management alpha weights and the subjective ratings, Niğde actually wins out the most favorable choices for the company. In the next video, we will cover rectilinear and Euclidean distance, the medium method, Manhattan distance, the gravity method, and the famous Field method. And that's all. Thank you for watching it.